Final question then of the Year 13 test. This is again the applied section. So we're looking at this mechanics question. We've got to find a cyclist going down a mountain. Fine, let's go ahead. First of all, we're asked to find the acceleration of the cyclist. So if we look at our suvat between P and R, we get S equals the distance travelled, which is not given. The U is the initial speed, which is 6. V is the final speed, which is 20. A is the thing we're trying to find, and T is 35 seconds. So I'm going to want to use V equals U plus AT to solve this one. And here V is, V is 20 and U is 6. A is the thing we're trying to find, and T is 35. So 14 equals 35A. So A is 14 over 35, which is 2/5. So A is 0.4 meters per second squared. Obviously, you can use different variations of that, some of which are simpler to get to, such as especially A equals V minus U over T. That would be more straightforward potentially. Okay, we're on to part B. We have to given a ratio between the T1 and T2, where T1 is the time to go from P to Q, and T2 is the time from Q to R, and that ratio is 4/3. Hence, we need to find the value of x, which is the speed when it reaches Q. So from that, we know that T1 plus T2 must equal 35. T1 plus T2 must equal 35 because that's the amount of time that it takes for the whole thing. If we look at this on a diagram, we've got P, Q, and R. The time taken to go from here to here, that's T1. Time to go from here to here, that's T2. And the total is 35 seconds. So that's why I can say that T1 and T2 is 35. I mean, that's obvious. But equally, I know that T1 divided by T2 equals 4 over 3. So that means that 3 T1 equals 4 T2. Or, if you prefer, I could write that 3/4 of T1 equals T2. Okay, so given that they add up together to make 35, I can now substitute in for T2. I can say T1 plus 3/4 of T1, that's T2, equals 35. So that's 1.75 times T1 equals 35. So T1 equals 35 divided by 1.75, which is 20. Therefore, T2 must be 15. Okay, that's very useful because that now allows us to go back and work out the time taken. We know the time taken to go from P to Q, so we can use the initial information and the acceleration that we just calculated to find the speed when it hits Q. Okay, so we have established that the acceleration is 0.4 meters per second in part A. We've just now established that the time taken to go from P to Q is 20. We know still that the initial speed is 6. So we can use that to calculate that V equals U plus AT. That's more than enough there. So V equals 6 plus 0.4 times 20, which gives us that V is 14 meters per second. All right, that was nice. That's 5 marks for that. I mean, there were a few steps of working. It does take a little bit of logic, but it still seems quite generous. All right, we're on to part C. And in part C, we're asked to calculate the distance between P and R. So we know that U plus V, the S is equal to average speed. So U plus V over 2 times time. Average speed times time give you the distance. So the average speed for this, given that it's got a constant acceleration, is going to be 6 plus 20, the initial speed, plus the final speed at r, all over 2, times by the time taken, which is 35, and if you calculate that, we get 455 meters. Okay, well done us. That's completed this. Please come and see your teacher if there's any parts you are unable to understand or would like some additional help with. Thanks.